Hi, in this video I want to talk about the operation of a motor. And a motor is almost the reverse of a generator. So with a generator, you spin a loop of wire in a permanent magnetic field and you generate an EMF because of the constantly changing magnetic flux through that loop. Well, if you run a current through that loop of wire, then you're going to produce a torque. And that torque is going to cause that loop to rotate. Now, at some point, the loop would rotate so that it would be aligned in the minimum of the magnetic potential energy. But as long as it doesn't start there, it would have some kinetic energy if you, at that minimum, were to flip the direction of the current, then it would want to experience a torque, causing it to keep rotating in that same direction. And as long as you keep flipping the direction of that current every half cycle, that motor is going to continue to run faster until it ultimately achieves its maximum speed. Well, you have a loop of wire that's spinning in a magnetic field. Motors are also generators too. And what happens is motors create a back EMF. So as the motor's operating, the operating current is much lower than the current required at starting because of that back EMF that's being generated. So say the coil in a motor has a resistance of 6 ohms, and we hook it up to a 120 volt power supply. Well, from Ohm's law, that means that our current would be 120 volts over 6 ohms, or 20 amps. Now for the power is the current squared times the resistance. So I have 400 amps squared times 6 ohms. That'll be 2,400 watts of power to get that motor started. Now to keep it going, let's say it generates a back EMF of 80 volts at full speed. So the operating current would be the source voltage minus the back EMF. So that means we would have a net of 40 volts acting on that 6 ohm resistor, which means we'd have 6.7 amps of operating current. Our operating power is our operating current squared times the resistance, so at peak operation, it only needs 270 watts of power to keep it going. Thanks for watching.